This is Pascal's triangle. You'll need it to know it for the binomial theorem, but you'll want to be able to make it yourself. Here's how you make it yourself. You start off with 1, and that's row 0, like something to the 0 power. And then you write a 1 and a 1 here. And then you extend the 1 out, but you add these two together to make 2, and you put 1 on the end. You extend the 1s out, and you add these two together to get 3. 2 plus 1 is 3. You keep extending the 1s out. You add the 1 and the 3 to get 4. 3 plus 3 is 6. 3 plus 1 is 4. And you can keep going forever, but I won't make you go past 12 or 14 in class. Now, what you should be paying to here is the relationship between these numbers and Pascal's triangle. Because if we take 1 and then we go 1, 1, that 1 represents the coefficient in front of the binomial expansion. If we then go 1, 2, 1, the 1, 2, 1 represents these coefficients. So if you had Mrs. Stoner last year, she really emphasized these problems, and if you had Mrs. Cessna, you just did them for one day. So you can decide for yourself, do I pause the video and write down this because I need to really think about it and then pause? Or if you've got it from last year, no big deal, just skip forward to the next slide. This is what the binomial expansion formula looks like in the book, and this is kind of what the example looks like in the book. So like if I had a plus, let's say, 2b to the 5th power, it would be to take a to the 5th plus 5 choose 1 times a to the 4th times b plus 5 choose 2 times a cubed b squared. I'm not going to write out the whole thing, but notice right here that 5 choose 1 is the number that's in the binomial expansion. So this is going to be 1a to the 5th, and it's going to be 5 a to the 4th, but in this problem, the b term is actually 2b, and so it'd be 5 a to the 4th times 2b, and so it's actually going to be 10 for that coefficient, but we'll get to that in a second. And then it's plus 5 choose 2. 5 choose 2 is 10, so it's going to be 10 times a cubed, but then b, remember, is really 2b. So it's 2b squared. And so I've sort of run off the screen. But if you were expanding this binomial with the binomial theorem, it would start off with a to the 5th plus 10 a to the 4th b plus 40 a cubed b squared dot dot dot. So I wanted to show you what the formula looked like because it's useful for our next slide. And that's the relationship between Pascal's triangle, which is right here, and the binomial expansions, which is right here, and that calculator NCR button. Because if you look right here, this coefficient is 5 choose 0, and this coefficient is 5 choose 1, and this coefficient is 5 choose 2, and this coefficient is 5 choose 3, and those are now looking at all of the different ways I could expand something that had 5 possibilities. This is 5 choose 4, this is 5 choose 5, and if I did those numbers using the NCR button, I would end up with 1, 5, 10, 10, 5, 1. It's important that you understand the relationship between Pascal's triangle and the part of the formula that looks like this, because if you know that this 5 choose 2 is the fifth row, or like the power of 5 row in Pascal's triangle, you should see the relationship between the row's power and the numbers in the binomial theorem. So this is what a binomial expansion looks like in your textbook, and I want you to like not get scared off by like the huge numbers here, and I want you to think about it in a little bit simpler terms. If this is a power of 5, that's the power of 5 row, which is the 1, 5, 10, 10, 5, 1 row. And this 1 is going to be your a to the 5th and no b's. And the 5 is going to represent the a to the 4th and the b. And the 10 is going to represent the a cubed and the b squared. I'm going to run out of room. And this next 10 is going to represent the a squared and b cubed. And the 5 is going to represent the a b to the 4th. And the last one is going to represent the no a's, just the b to the 5th. But what happens in each of these steps, they're going to have the coefficient that goes with Pascal's triangle in front of it. So this will have a 5, and this will have a 10, and this will have a 10, and this will have a 5, and this will have a 1. So when you're looking at these 5 choose zeros and 5 choose ones and 5 choose twos and 5 choose threes and all these fancy things in the formula, you're really just looking at the green numbers down here, 1, 5, 10, 10, 5, 1. So you don't have to think about that part too much. But now what you do have to think about that's sort of tricky is the b in this problem is 2y. So wherever there's a b, I've got to replace it with a 2y. So this 2y gets squared, and this 2y gets cubed, and this 2y is taken to the 4th power, and this 2y is taken to the 5th power, and you also have to think about signs because all of these 2y's are negative 2y's. Okay, so let's see if I can fit this all in one screen. So the a to the 5th is just the a to the 5th. The 5 times a to the 4th times negative 2y becomes negative 10. Oh, except for a is x, sorry. All my a's are x's. X to the 5th. It's 10 x to the 4th. Negative 2 times 5 is negative 10, so it's x to the 4th y. For my next one, the negative is squared, so it's going to be positive 4 times 10. So it's going to be plus 40 x cubed y squared. In this next piece right here, the negative 2 is cubed, so a negative cubed is going to be negative, and 2 cubed is 8. So that's going to become negative 80 x squared y cubed. And this next one right here is going to be 5 times negative 2 to the 4th, so that's 5 times 16, that's 80. It's a positive 80. Xy to the 4th, and I still didn't quite fit it, minus 32 y to the 5th. Okay, so that's it, a binomial expansion. If you had Mrs. Stoner, you probably are sick of these and can do them while you're asleep, and otherwise you need to practice up a little bit, and hopefully you understand where all the numbers come from. If not, just watch the last 4 minutes over again. Oh, what the heck, I figured I would do just one more. So this is a cubed problem. So there's our 0 row, here's our 1 row, here's our 2 row, here's our 3 row. Okay, so I'm going to write this as 1 m cubed plus 3 m squared w plus 3 mw squared plus 1 w cubed. And then I'm going to go, oh yeah, but it's not really a w, it's a 3w. So wherever there's a w, I'm going to replace it with a 3w. This 3w is going to be squared. This 3w is going to be cubed. And now to complete the binomial expansion, it's m cubed plus 3 times 3, so back that up, or erase it. 9 m squared w plus, and now on this problem we've got 3 times 3 squared, so 3 times 9 is 27 m w squared, and here we have 27 w cubed. So if you think back to that one formula that looked really complicated, it's much easier to think about it with Pascal's triangle. Your homework assignment is going to include some of these problems, but we're also going to do some probability problems because the binomial expansions are pretty easy. It's the probability people get hung up on.